Okay, good evening everyone. This is the 12th live discussion session for the course Geotechnical Engineering 1. The topic of today's discussion is settlement of compressible soil layers. In the previous class, I have already talked about the consolidation part, the basic concepts with some numericals. In this session, we are going to delve deeper into the concepts of settlement in soil layers using the various factors like coefficient of permeability, coefficient of compressibility, coefficient of volume change, coefficient of consolidation, etc., etc., degree of consolidation, time factor, everything. So this is the last discussion session, problem solving session. I think tomorrow they are going to be summary session from 4 to 5. I hope the mail has been forwarded. I'll talk about it later in the sessions also. Since no one has joined yet, I'll start with dictating the questions. If anyone you join, you start writing the questions. Okay, I'll now straight away go to the PowerPoint presentation. Yes, I hope the PPT is visible to everyone. So I'll just wait for a couple of minutes. Let's see if someone joins. Otherwise, I'll start after a minute. Okay, so now it is almost 6 minutes past 6 o'clock. So I'll start dictating the questions right away. Those who will join the meeting, they can start their question writing from that particular slide. Okay, so once again, good evening everyone. This is the 12th live discussion session of the course Geotechnical Engineering 1. The topic of today's discussion is settlement of compressible soil layers. Like the previous session, this session also has a set of questions combining multiple choice questions, true or false statements, and some numerical. This particular session has some more numericals, because in the last class, in the chapter of consolidation, I have mainly dealt with the concepts, and in this chapter the problems with respect to the settlement of soil layers has been given. So because of this, I'll start dictating the questions right away, and those of you who will join, you will get some time after I dictate the questions, approximately 15 minutes, after which I'll again start in the same Google Meet link. I'll again start and discuss the solutions. Okay, so I'll go to the first question. Okay. The ultimate settlement of soil is a function of. The ultimate settlement of soil is a function of. Your options are coefficient of volume change, increment in effective pressure, thickness of the soil layer, or all of these? Sorry. I repeat the question. The ultimate settlement of soil is a function of. Okay, just wait, someone has joined. Yes, Abhinaya, I have already started dictating the questions, but this is the first question. You can start writing the questions. Okay, this is the 12th discussion session. The topic is settlement of compressible soil layers. Okay, I hope the PPT is visible and I am audible to you. If there is any problem, you can just let me know by telling me or just using the chat box. So, this is the first question. The question is, ultimate settlement of soil is a function of, first option, coefficient of volume change, second option, increment in effective pressure, third option, thickness of the soil layer, and last option is all of these. Okay. Sorry. Next question. Settlement of a soil layer at any time with respect to the ultimate settlement yields. The options are coefficient of volume change, degree of consolidation, coefficient of compressibility, or coefficient of permeability. I repeat the question. Settlement of a soil layer at any time with respect to the ultimate settlement yields. The options are coefficient of volume change, degree of consolidation, coefficient of compressibility, or coefficient of permeability. Okay. Next question. Consolidation settlement can be computed by using. The options are coefficient of volume change, voids ratio, both of the above, or none of these. I repeat the question. Consolidation settlement can be computed by using. The options are coefficient of volume change, voids ratio, both of the above, or none of these. Okay. Next question. Final settlement is small in case of pre-consolidated soils as the recompression index is very small compared to compression index. Final settlement is small in case of pre-consolidated soils as the recompression index is very small compared to compression index. Is this statement true or false? I hope you are familiar with the concept of recompression index and compression index. I repeat the statement, final settlement is small in case of pre-consolidated soils as the recompression index is very small compared to compression index. Is this statement true or false? Sorry. Next question. Yes, I think now the numericals are starting. Please write down the data very carefully. A fully saturated clay specimen is placed in a consolidometer and 2 kg per centimeter square is applied. There is a force of 2 kg per centimeter square is applied. After some time, the pore pressure is found to be 0.6 kg per centimeter square. Find the corresponding value of settlement if the ultimate settlement is going to be 20 millimeter. I repeat the question. A fully saturated clay specimen is placed in a consolidometer and 2 kg per centimeter square is applied. After some time, the pore pressure is found to be 0.6 kg per centimeter square. Find the corresponding value of settlement if the ultimate settlement is going to be 20 millimeter. Okay. Next question. A settlement analysis carried out for a proposed structure indicates that 9 centimeter of settlement will occur in 5 years and the final settlement will be 45 centimeter based on double drainage conditions. A detailed site investigation indicates that only single drainage occurs, considering the degree of consolidation to be less than 60%. Estimate the settlement at the end of 5 years for the changed condition. In this case, you have to consider that the final settlement will be same. Okay, final settlement will be 45. Based on that, the condition is changing. That is, now it is single drainage condition. So, what will be the settlement at the end of 5 years for this changed condition? I repeat the question. A settlement analysis carried out for a proposed structure indicates that 9 centimeter of settlement will occur in 5 years and the final settlement will be 45 centimeter based on double drainage conditions. A detailed site investigation indicates that only single drainage occurs. Considering the degree of consolidation to be less than 60 percentage, estimate the settlement at the end of 5 years for the changed condition. Next question. A clay layer 8 meter thick is subjected to a pressure of 70 kilonewton per meter square. If the layer has double drainage and undergoes 50% consolidation, for which the time factor Tv equal to 0.196 in 1 year, determine the coefficient of consolidation, that is Cv. If the coefficient of permeability is 0.04 meter per year, determine the settlement in 1 year. Take the unit weight of water as 9.81 kilonewton per meter cube. I repeat the question. A clay layer 8 meter thick is subjected to a pressure of 70 kilonewton per meter square. If the layer has double drainage and undergoes 50% consolidation, Tv equal to 0.196 in 1 year, determine the coefficient of consolidation. If the coefficient of permeability is 0.04 meter per year, determine the settlement in 1 year. Take the unit weight of water as 9.81 kilonewton per meter cube. I hope the question was clear. I will go to the next question. This is a pretty long question, please write down carefully. A soft normally consolidated clay layer is 20 meter thick with a moisture content of 45 percentage. The clay has a saturated unit weight of 20 kilonewton per meter cube, a particle specific gravity of 2.7 and a liquid limit of 60 percentage. A foundation load will subject the center of the layer to a vertical stress increase of 10 kilopascal. Groundwater level is at the surface of the clay layer. Estimate number 1, the initial and final effective stresses at the center of the layer. Number 2, the approximate value of the compression index. And number 3, the consolidation settlement of a foundation above the layer. Take unit weight of water as 10 kilonewton per meter cube. I repeat the question. A soft, normally consolidated clay layer is 20 meter thick with a moisture content of 45%. The clay has a saturated unit weight of 20 kilonewton per meter cube, a particle specific gravity of 2.7 and a liquid limit of 60%. A foundation load will subject the center of the layer to a vertical stress increase of 10 kilopascal. Groundwater level is at the surface of the clay layer. Estimate number 1, the initial and final effective stresses at the center of the layer. Number 2, the approximate value of the compression index. And number 3, the consolidation settlement of a foundation above the layer. Take unit weight of water as 10 kilonewton per meter cube. Okay, I hope the question was clear. I will go to the next question. Yes. A 20 meter thick clay layer is sandwiched between a silty sand layer and a gravelly sand layer and experiences 30 millimeter settlement in 2 years. If the coefficient of consolidation of the layer is 0.003 centimeter square per second, calculate the extra time required for the soil to achieve a total of 50 mm settlement. Here I am asking about the extra time required and not the total time required. Okay. It has already experienced 30 mm settlement. In how much extra time will it experience a total of 50 mm settlement? I think you are late to join today. Someone is joined right now. ARB. This is, I think, the ninth question I am discussing. You can start from here and then continue your solutions when I start discussing. Okay. This is the ninth question. I repeat, a 20-meter thick clay layer is sandwiched between a silty sand layer and a gravelly sand layer and experiences 30 settlement in 2 years. If the coefficient of consolidation of the layer is 0.003 centimeter square per second, calculate the extra time required for the soil to achieve a total of 50 settlement. Just find out the extra time required for the excess amount of settlement for the complete settlement of 50 Okay. Okay. Next question. The average effective overburden stress on 10-meter thick homogeneous saturated clay layer is 150 kilopascal. Consolidation test on an undisturbed soil sample taken from the clay layer showed that the void ratio decreased from 0.6 to 0.5 by stress increment from 100 kilopascal to 300 kilopascal. Calculate number 1 the initial void ratio of the clay layer. Number 2 the total consolidation settlement of the clay layer due to construction of a structure imposing an additional stress intensity of 200 kilopascal. I repeat the question. The average effective overburden stress on 10-meter thick homogeneous saturated clay layer is 150 kilopascal. Consolidation test on an undisturbed soil sample taken from the clay layer showed that the void ratio decreased from 0.6 to 0.5 by stress increment from 100 kilopascal to 300 kilopascal. Calculate number 1 the initial void ratio of the clay layer, and number 2 the total consolidation settlement of the clay layer due to construction of a structure imposing an additional stress intensity of 200 kilopascal. Okay. Next question. At a given site A having a clay layer 8 meter thick with single drainage, a uniform fill that was constructed resulted in a settlement of 5 centimeter in 1 year, corresponding to 50% average degree of consolidation. It was found that at a neighboring site B, the same type of soil exists, but the thickness is 16 meter. How long will it take for 50% consolidation to occur, and what will be the magnitude of settlement if a fill of the same magnitude as at site A was to be constructed at site B? I repeat the question. At a given site A having a clay layer 8 meter thick with single drainage, a uniform fill that was constructed resulted in a settlement of 5 centimeter in 1 year, corresponding to 50% average degree of consolidation. It was found that at a neighboring site B, the same type of soil exists, but the thickness is 16 meter. How long will it take for 50% consolidation to occur, and what will be the magnitude of settlement if a fill of the same magnitude as at site A was to be constructed at site B? Okay. Is the question clear? Any doubt regarding the question?
Last line I could not understood.
Which one? How long will it take from there?
No, 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 last line. If the fill of
If a fill of same magnitude, yes, the soil layer, okay, in site A, okay, soil layer in site A and site B, they are same with different thicknesses. Now the settlement and load whatever is resulting in site A, it is because of a particular fill imposed on it, okay, that is giving the stress. If the same fill, that is the same type of overburden stress was there in site B, how long will it take for 50% consolidation to occur? I have written over here fill, right? Instead of fill, if I say that a structure was made in A which resulted in this kind of settlement in 1 year, 5 centimeter. The same structure made in site B, how long will it take? Okay, fill means the type of overburden soil which is causing the stress to occur.
okay, sir.
Yeah. Okay, so next question. A layer of normally consolidated saturated clay of 1 meter thickness is subjected to one dimensional consolidation under a pressure increment of 20 kilopascal. The soil has specific gravity of 2.7, natural moisture content of 45 percentage, compression index of 0.45 and recompression index of 0.05. The initial average effective stress within this layer is 100 kilopascal. Determine the primary consolidation settlement of the soil layer. I repeat the question. A layer of normally consolidated saturated clay of 1 meter thickness is subjected to one dimensional consolidation under a pressure increment of 20 kilopascal. The soil has a specific gravity of 2.7, natural moisture content of 45 percentage, compression index of 0.45 and recompression index of 0.05. The initial average effective stress within the layer is 100 kilopascal. Determine the primary consolidation settlement of the soil layer. Okay, next question. A 4 meter thick normally consolidated clay has an average void ratio of 1.3. Its compression index is 0.6 and coefficient of consolidation is 1 meter square per year. If the increase in vertical pressure due to foundation load on the clay layer is equal to the existing effective overburden pressure, calculate the settlement of the clay layer. After I finish dictating the questions, the numericals you have missed, okay, I will show you, just take a screenshot. Okay, I think there are only 4 numericals left before the ninth one, ninth question. Would you do it? If I show you the previous question, can you take a screenshot of the same?
Yes, sir.
Okay, so let me finish dictating the questions. I will just show you the numericals, take a screenshot. Okay. Okay, so this question was, I'll repeat once, a 4 meter thick normally consolidated clay has an average void ratio of 1.3. Its compression index is 0.6 and coefficient of consolidation is 1 meter square per year. If the increase in vertical pressure due to foundation load on the clay layer is equal to the existing effective overburden pressure, calculate the settlement of the clay layer. Next question. In a consolidation test, the void ratio of the specimen, which was 1.068 under the effective pressure of 214 kilonewton per meter square, changed to 0.994 when the pressure was increased to 429 kilonewton per meter square. Calculate the coefficient of compressibility, compression index, and the coefficient of volume compressibility. Find the settlement of foundation resting on the above soil if the thickness of the layer is 8 meter and the increase in pressure is 10 kilonewton per meter square. To note, this increase in pressure is increase on the initial pressure, that is 214. Okay.
Sir,
Yes.
if the increase in the pressure is almost 10 is like a zero, no, then in that case settlements will be zero.
Why 10 is like 0?
Compare normally the building loads or something will be more
No,
than
see,
100
it is
kg at 150
upon here
kg.
I have told you that it is 10 increase from 214 is the initial. Okay, so it has some percentage, and if you say like that, and I will see, in the numerical that this one is third last. Okay, this one is third last. Yes, the settlement is very less, but again, in
Okay.
case of settlement, even in millimeters, okay, it is kind of significant because it is a
Okay.
time dependent process, no. So whatever we get in the field or in the calculations, it is significant. Okay. So the answer, if it is very less, like in millimeters, 10 to the power minus
Yes,
3,
sir.
10 minus
Understood.
4,
Understood.
it is of no worries about that.
Negligible.
Yeah.
Okay.
Okay, I repeat the question. In a consolidation test, the void ratio of the specimen, which was 1.068 under the effective pressure of 214 kilonewton per meter square, changed to 0.994 when the pressure was increased to 429 kilonewton per meter square. Calculate the coefficient of compressibility, compression index, and the coefficient of volume compressibility. Find the settlement of foundation resting on the above soil if the thickness of the layer is 8 meter and the increase in pressure is 10 kilonewton per meter square. Okay. Next question. A normally consolidated clay settled, okay, I have mentioned here twice, sorry for that, settled by 2 centimeter when the effective stress was increased from 100 kilopascal to 200 kilopascal. Calculate the settlement when the effective stress is increased to 400 kilopascal and 800 kilopascal. I repeat, a normally consolidated clay settled by 2 centimeter when the effective stress was increased from 100 kilopascal to 200 kilopascal. Calculate the settlement when the effective stress is increased to 400 kilopascal and then to 800 kilopascal. Means individually when it is increased to 400 kilopascal, the settlements I will write over here, settlements. Yes, what is the settlement, and when the effective stress is increased to 800 kilopascal, what is the settlement? Okay. Next question. A saturated soil has a compression index of 0.28. The void ratio at a stress of 12 kilonewton per meter square is 2.05 and its permeability is 35 into 10 to the power minus 7 millimeter per second. Calculate number 1, the change in void ratio if the stress is increased to 21.6 kilonewton per meter square. Number 2, the settlement in 1 if the soil is 6 meter thick, means in the condition when the stress is increased to 21.6 kilonewton per meter square, first of all find the change in void ratio, and in that situation in the second part find out the settlement if it is mentioned that the soil is 6 meter thick. Here the compression index is 0.28 and the void ratio at a stress of 12 kilonewton per meter square is 2.05 with the permeability equal to 35 into 10 to the power minus 7 millimeter per second. Okay. Shall I show you the previous sums? You can take a screenshot. Hello? Are you there?
Okay, sir.
Yeah. So from this question you started writing,
Okay.
right? From this question. Isn't it? 20 meter thick clay layer. Anyway, this was the previous question. Please take a screenshot.
Yeah.
Yes. Then this was the question previous to that. Clay layer to a pressure of 70, double drainage, 50% consolidation, TB 0.196 in 1 year. Find the coefficient of consolidation, this is CV. Then K is given 0.04 meter per year. Find the settlement in 1 layer. Unit weight 9.81. Okay. And previous to this one was this one.
Okay, sir.
Settlement analysis for a structure. Take a screenshot.
And sir,
Yeah, and previous to that it was this sum. Okay. I am not showing you the MCQ because the MCQs are very small part of today's lecture. I won't be spending much time on them. I will be focusing directly on the numericals. Okay. So you start solving this.
okay, sir.
Okay. I will start discussing
Right.
the solutions at around 7:05 or 7:06. Okay. You get 15 minutes of time.
Yeah.
Solve it. Okay. Okay. Yeah.
7:10, sir.
You need. Okay. I'll start at 7:10. Okay. Fine. Fine.
Yes, sir.
I'll start at 7:10.
Thank you,
Chalo.
sir.
Okay. Yeah. Hello. Have you solved some questions, if not all? Please let me know if you are there in the meeting. Hello. I hope you are there in the meeting. I'll start discussing the solutions now. If you have solved it, please correlate the same with the solutions I'm telling. Okay. So the first question was, the ultimate settlement of a soil is a function of coefficient of volume change, increment in effective pressure, thickness of soil layer. So the ultimate settlement final it is dependent on all three. Okay. So the answer is all of these. The answer is all of these. Okay. It depends on coefficient of volume change mv, increment in effective pressure del sigma, and thickness of soil layer h0, initial thickness. Okay.
Okay, sir.
Next question. Settlement of a soil layer at any time with respect to ultimate settlement yield. Settlement of a soil layer, suppose it is rho, with respect to the ultimate settlement, if I express that in percentage, it becomes u, that is the degree of consolidation. It is the degree of consolidation. Okay. Next question. Consolidation settlement can be computed by using coefficient of volume change, void ratio, both of the above. The answer is both of the above. Using coefficient of volume change method and the change in void ratio method, you can find out the consolidation settlement. For detail, you can check any standard textbook. You will get the methodology in details. Okay. So the answer is both of the above. Using coefficient of volume change and void ratio, you can find out the consolidation settlement. Okay. Sorry. Next question. Final settlement is small in case of pre-consolidated soils, as the recompression index very small to the compression index. Compression index is Cc, recompression index or swelling index is, sorry, it is Cs. We know that recompression or swelling index is approximately 1/5 to 1/10 of the compression index Cc. For this reason, soils which are pre-consolidated, they swell and then again they start consolidating, and in their case, this being very less, the final settlement is small. Hence, this is a true statement. The recompression index very small compared to the compression index, so final settlement is small in case of pre-consolidated soils. Okay. Next question, the first numerical. Have you solved this? I think a similar sum I had already discussed in the last class. What was your answer?
14 millimeter.
Yes, 14 millimeter. So the effective stress. Okay, since there are many sums, okay, I am pre-assuming that you already know the concepts. I'll just focus on the methodology and the formulas. Okay.
Yes.
So it is total stress minus the pore pressure. So the effective stress will be 1.4 kg per centimeter square when the pore pressure is 0.6. Final effective stress When the pore pressure is 0, it will be how much? It will be 2 kg per centimeter square. Now, degree of consolidation, as we know, rho by rho f, which is also equal to sigma by sigma f. So, you can mute yourself if you are not speaking. There is a noise coming. So, it is rho by rho f into, sorry, sigma by sigma f into rho f. What is rho f? Rho f is 20. Rho f is 20. So, it is 20 mm. So, it is 14 mm. Okay. Next question. I'll save it this moment. Yes, have you solved this question?
No, sir, not yet, sir.
Okay, so I'll just tell you, U is equals to rho by rho f into 100%. Now it is 9 and 45. Based on that, it is 20 percentage. From there, TV you can find out how. What is the formula? For U less than 60 percentage, TV equals to pi by 4 U by 100 whole square, right? You can find out TV. Time is given as 5 years. This is the time T. Okay. Now, TV is equals to CVT by D square. Here, at first we are considering double drainage. So, at first initially it is H by 2 whole square. From here, you calculate the value of CV by H square. We don't know anything. So, not like this. H square, yes. That will be equal to, if you put the values, find out TV and put the value of T from the respective change the respective units, you will find the value of this is approximately 1.571 into 10 to the power minus 3. Now, for the change condition, that is for single drainage, TV will be equals to how much for single drainage? Single drainage, TV will be equals to CVT by H square, not H by 2 whole square, right? H square. Now, CV by H square we already know, time is 5 years, and this is equals to how much? TV equals to again pi by 4 U by 100 whole square, isn't it? Or from here we know T, we know CV by H square. Okay. Now, from here find out the value of U. U will get as equal to 10 percentage. Now, I had already mentioned, I think you have missed it, but while dictating the question, that the final settlement will be considered as 45 only. Okay, 45. So, the final settlement is 45 for 10% degree of consolidation. What will be the settlement? So, this is equals to rho by rho f is 45. Okay. So, 10 by 100. So, rho for the change condition will be how much? 4.5.
4.5 centimeters.
Yes, 4.5 centimeters.
Yeah, I have done, sir. I have done it actually. I
Oh,
forgot
okay.
to tell you.
Okay, okay, good, good.
Yes, sir.
Okay. So, the sums are almost similar, just a
Sir,
few changes. Yes, yes, yes.
here directly we can eliminate the CV also, no, sir?
Yes, we can do it in
Because
any way,
sorry, this.
anyway. Yes, yes, you can do it in
Okay.
any way, whatever is possible. I am
Yeah.
just showing you one method and one particular direction of solving the sum. You can do it in your own way. The concept should be
Okay.
same and it should be clear. That is the main priority. Okay, so next question was this is a clay layer subjected to pressure of 70. Okay, so TV has been given over here and it was told here double drainage. Have you solved this question? Have you solved this question?
Yes, sir.
What was your answer for
Yes,
50%?
sir.
50%.
C, you want CV or settlement?
Uh,
There are
First, tell
two
me the value of
questions.
CV. Tell me the value of CV.
CV is 3.136 meters square per year.
Very good. What is the settlement?
89 centimeters
89 centimeters.
or 0.89 meters.
No. I think something is wrong.
Yeah, I
Okay.
thought of that value because settlement. Okay.
Yeah. Okay, let's see.
CV
Let's
is
check.
correct, sir. CV is correct, sir.
CV is absolutely correct. Okay, so the value of the formula you
Okay.
have used over here will be this one, right? CVT by D square. So CVT by H by 2 whole square, isn't it? Now from here, now TV has been given over here. H is how much? 8 meter thick. Okay, 8 meter thick. So H by 2 4 square 16. So CV will be equals to 0.196 into 16, that is 3 point, yes, 3.136 meter square
Six, sir.
per year. Okay, this is correct. Now have you found out the value of MV?
Yes, sir.
What was,
1.3 into 10 power minus 3.
yes, CV gamma W 9.81, 1.3 into 10 to the power minus 3 meter square per kilonewton, isn't it? Now the final settlement will be how much? MV del sigma into H0. So what is the value? Multiply MV and del sigma and H0, that is the height of thickness of 8 meter, del sigma is 70, the value you are getting is 0.728 approximately, right? Meters, in meters. Any doubt?
No, sir. Last small mistake I have done. That's all.
Oh, okay.
Otherwise, it's okay.
Yeah, so after finding out the final settlement, you have to find out 50% consolidation, this is half settlement. So rho 50% will be half of this, rho f divided by 2 equal to 0.364 meter. Okay, 0.64 meter in 1 year, because 1 year corresponds to 50% consolidation. Okay. Next question. Yes, tell me, you have solved this, if you have solved this step by step, 1, 2 and 3.
No, sir. Remaining all I could not do it. So time is not sufficient.
No problem. I will just do it, just follow. Okay. So the first case, finding out the initial and final effective stress. Initial effective stress equals to how much? Gamma submerged into H. Gamma submerged means gamma sat minus gamma W. Gamma sat minus gamma W into H at the center of the clay layer, that is half of the thickness, that is 10. So it is 100 kilonewton per meter square. Okay. What is the final? What is the final? Initial plus change in the stress, change in stress, that is 10, 110. The change is 10, right? Increase in 10 kilopascal. Kilopascal and kN per meter square, same thing. So it is 110. Now number 2, find out the compression index, value of compression index Cc equals to 0.009 into liquid limit minus 10. What is the value of liquid limit? 60%. So put 60 minus 10, then multiply with 0.009, it is 0.45. 0.45. Okay. Now before finding out the settlement, do one thing, find out the value of the initial void ratio, E0. The soil is saturated, so Wg by S, that is W sat moisture content into G, S is equals to 1. Okay. W sat, how much moisture content? It is 0.45. Okay, and G is 2.7. Approximately, I believe it will be 1.215. 1.215. Now find out the value of settlement. Del H or rho, whatever. Cc divided by 1 plus E0, 1 plus E0, H0, initial height, initial thickness, log to the base 10, sigma final minus sigma initial. Okay. So, final sigma is 110, initial is 100. Okay. H0 is 20. Oh, 20 is the thickness of the clay layer. Okay. 20 is the thickness of the clay layer. Cc we have found out 0.45, E0 is 1.215. Put the values, you will get approximately 16.82. centimeters, 16.82 centimeters. Okay.
Okay, sir.
Yeah, these formulas are given in any standard textbook. You can see, find out how they are being formulated. Next question, 20 meter thick clay layer sandwiched between. Okay, so tell me one thing, sandwiched between silty sand and gravelly sand layer. So it is double drainage or single drainage?
Double drainage.
Yes, good. So first of all, we will see, we can find out the value of TV, time factor, CVT by H by 2 whole square. Okay. CV is 0.003. Okay. Time is 2 years, convert these years into seconds, first days, then hours, then minutes, then seconds, and then this one, the height, that is the thickness of the layer in centimeters. Okay, you get TV approximately equal to, I will say 0.1892. Now assuming that the U is less than 60%, so TB, this value will be equals to pi by 4 U by 100 whole square, and from here you will get U in fraction 0.4908, that is 49% degree of consolidation. Okay. So this assumption was right, that is U was less than 60%, yes, of course. Now this value of U, we know it is equals to settlement by ultimate settlement. Okay. Now the ultimate settlement has been given in 2 years, it is 30 mm. So rho f or the ultimate settlement will be equals to rho by degree of degree of consolidation, that is 30 divided by U. Okay, that will be approximately equal to 61.12 millimeter. Okay, now we have been told to find out, for 50 mm settlement how much time needed. So first of all, we will see that for 50 mm settlement, what is the degree of consolidation. So that is 50 divided by U equals to 50 divided by final, that is 61.12 into 100, we get approximately 81.8%. Now for this, time factor has a separate formula. What is the formula for time factor? When U is more than 60%, 1.781, yes, 7813 minus 0.9332 log to the base 10, 100 minus U. Using this formula, calculate, I will star mark over here because of the space problems. I find out the value of TB to be equals to approximately 0.6 that's not right, 0.6054. Okay. Now, double drainage condition still prevailing, the time taken will be from the first formula will be TV into H by 2 whole square divided by CV. Okay. Putting all the values, we will get approximately 6.4 years. Now, total time till 50 mm is 6.4 years. What is the extra time taken? It will be 6.4, that is del T. 6.4 minus 2 years, that is 4.4 years. So, it will take 4.4 years more to reach up to 50 mm of settlement. Okay.
Right, sir.
Yes. Next question. Just a moment, I am not checking whether average effective overburden stress. Yes. Okay. So, in this question, we will first focus on the second part, 0.6 to 0.5, 0. From this one. So, we know the value of Cc equals to change in void ratio divided by log to the base 10 final sigma by initial sigma stress. Now, change in void ratio, it is 0.1 log to the base 10 300 by 100, I believe you will get approximately 0.21. Okay, 0.21. Now, in initial stage, for when E equal to E0, at that time the sigma 0 was how much? 150 kilopascal, isn't it? So, now taking 0.6 for 100 kilopascal as a reference. So, I will do it here, 0.6 minus E0, because 150 is more than 100. So, E0 will be less than 0.6 divided by log to the base 10 150 divided by 100, isn't it, is equals to Cc, that is 0.21. You solve it, you will get E0 approximately equal to 0.563. 563. The 0, it became like a quadrilateral. Anyway, 0.563, okay, initial void ratio. Now, the total consolidation settlement of the clay layer, additional stress intensity of 200. Now, this 200 is upon the initial pressure, that is from 150. So, we will use a general formula for settlement, rho equals to Cc by 1 plus E0, height, sorry, not the height, thickness, this 10 meter thickness, log to the base 10, sigma, that is 150 plus del sigma, that is how much? 200, right, 200 divided by 150. Solve it, get a value 0.21 by 1 plus 0.563, h equals to 10, you get a value of approximately 0.5 meter, 0.5 meter. Clear?
Yes, sir.
Yeah. Okay. Next question. At a given site A. Okay. So, now see, the soil is same, okay, the soil is same and the degree of consolidation is same. So, over here TV and CV both are same, right, same type of soil and same degree of consolidation, 50% average degree of consolidation. So, now we can say that time taken, not I will write TA by TB, easy to understand, is equals to h1 by h2 whole square, right? Ha by hb whole square, right? From the general formula, Ha by hb whole square. Now what we are told to find out initially, how long will it take? So Tb we have to find out. Tb is equals to what? Ta into hb by ha whole square. What is Ta? 1 year. What is hb? 16 divided by ha 8. 16 by 2, 2 square 4. So the value of Tb is 4 years. It will take 4 years to achieve the same degree of.
Sir,
Yes.
you can assume any drainage, na, since it's not mentioned.
Yes, obviously any drainage. Same condition.
Okay.
Okay, same condition, same thing. So double drainage, 2 gets cancelled. Single drainage, there is
Cancel
the
that.
question of 2. Okay.
Okay.
Yeah. Again, in the same condition, we know the settlement del H is equals to mv del sigma H0. Same condition, del sigma is same, mv is same. So I will write like this, that del H is a settlement. Okay. So rho settlement in A divided by settlement in B is directly proportional to thickness of A divided by thickness of B. Okay. So the settlement obtained in B is equals to rho A into HB divided by HA. What is rho A? It is 5 centimeter. HB 16 by 8. So 5 into 2, 10 centimeter. So it will take 4 years for the soil at site B to undergo 50% consolidation, and the settlement will be approximately 10 centimeter. Okay.
Right, sir.
I'll save it first. Yeah. I hope it is recording. Yes, it is. Thankfully. Yes, a layer of normally consolidated clay, saturated clay of 1 meter thickness. Initial effective average primary consolidated settlement of the layer. Okay. So I'll first see here we have Cc, we have the value of Cc, compression index, we have. Okay, we have the value of compression index. Now E0, to find out E0, initial void ratio, again the same thing, saturated. So S equals to 1, we get similar value 1.215. Okay, 1.215. Now initial effective stress 100, final 20, final is 20. So just use the normal formula, Cc divided by 1 plus E0. This is a similar question, just for practice. Sigma f by sigma 0 effective. Now sigma f is how much? This value is how much? 120, because 100 plus 20. This value is how much? 100. What is the value of H? H is 1. Cc is 0.45. Okay, putting all the values over here, approximately 16.08, something like that you will get. Sorry, not centimeter, millimeter. 16.08 millimeter. Okay. So the recompression
Right.
index is not necessary over here,
Yes, sir.
just
Yeah.
an extra parameter given, sometimes to confuse people, but anyway. 4 meter thick normally constituted clay has an average void ratio of 1.3. Okay. So, again over here I will first of all use the formula. So, the compression index is 0.6. So, if I use the formula, again the same formula, rho equal to Cc divided by initial void ratio is given 1.3, 1 plus E0 initial thickness into log to the base 10. Now, increase in vertical pressure is equal to the existing vertical pressure. So, sigma plus increase in sigma is equal to sigma divided by sigma. Okay. So, there is no need to know the value of sigma, because the increase in sigma is equal to the value of effective, that is sigma. Del sigma equal to sigma over here. Del sigma effective equal to sigma effective. So, it will be 2 by 1, and the other values Cc is given, E0 is given 1.3, H is given over here 4 meter. Just find out the value of the settlement. Approximately I have got over here 314. You can solve it and find it out. Okay. So, here it is a very simple question. The only thing you need to observe very carefully is that the increase in vertical pressure due to the foundation load on the clay layer is equal to the existing effective overburden pressure. Their del sigma equal to sigma. So, we write over here, right, sigma effective plus del sigma divided by sigma effective. So, del sigma equal to sigma. So, it becomes Cc by 1 plus E0 H into log to the base 10 2 by 1, log to the base 10 2 by 1. Okay. It becomes 314 millimeter. Okay.
Right, sir. No need of CV.
No need of CV. Again, an extra parameter given, just
Subtest,
you know, yeah. Now, in this sum, in the next sum, just a moment, I will just check. Okay, it is recording. Yes. In the next sum, you will be needing everything. So, you have so many things given over here. Void ratio 1.068 under effective pressure was 214, changed to 0.994, pressure was increased to 429. So, the initial condition will be taken as 1.068, okay, and initial effective pressure will be 214 for the final case also. So, now first of all the coefficient of compressibility, the coefficient of compressibility. So, AV, this is the coefficient of compressibility. What is the formula? Change in void ratio divided by change in effective pressure. What is the change in void ratio? It is 1.068 minus 0.994. Change in effective pressure, obviously 429 minus 214. You get a value of approximately 3.442 into 10 to the power minus 4, yes, minus 4 meter square per kilonewton. Okay, meter square per kilonewton. Now, then the compression index Cc. Cc, the formula is again del E divided by log to the base 10, logarithmic difference, sigma final by sigma initial. I will write like this. So, again this difference and log to the base 10, sigma final is 429, sigma initial is 214, put the values, you will get approximately 0.245 value of Cc. Okay. Now, over here I have asked you to consider this as E0, this as E0, the initial void ratio. For finding out the value of the coefficient of volume change or coefficient of volume compressibility, the formula is coefficient of compressibility divided by 1 plus initial void ratio. AV you have found out initially 1 plus E0, the value you get approximately E0 is 1.068, okay. It is 1.664 into 10 to the power minus 4 again meter square per kilo Newton. Okay. So, thickness is 8 meter, increase in pressure is 10. So, now for the settlement part, formula is Cc by 1 plus C0 H log to the base 10. I will write it over here, that is this. Okay. Sigma.
What formula you can use, sir?
Yes, yes.
You can use the MB into delta sigma into H, na,
Yes,
sir?
yes, that also we can use. Okay, you do one thing, you use that formula and you just find out the answer. Let's see if there is any variations. Okay, there won't be, obviously.
1.33 I got.
1.33
Yeah,
in
centimeters. Centimeter.
centimeters. 1.33. You used MV del
Multiply by
sigma.
delta sigma into H.
Let me check. 1.664 into 10 to the power minus 4 into del sigma is 10 into 8. Okay, okay. This is what happened last time also. Now use this formula and find out. Okay, okay, okay. No, you cannot use that formula. No, because that is for the ultimate settlement formula. Okay, that is for the ultimate settlement formula. Wait, 18.8. But that is the, that can be used in between also, I believe, if the effective pressure. Anyway, tell me the value you are getting over here. I'll have to see. What is the value you are getting over here?
I didn't do it.
Yes, please do it now. H is 8 into Cc 0.245 divided by 1 plus 1.068. I am getting 18.8 millimeter. This formula, this when you use the ultimate settlement, it is generally used for ultimate settlement, right? So, I believe this will be applicable over here, this formula, because yeah, I have done that using that formula also, but the value what we are obtaining is not correct as per the value of ultimate settlement will be, because anyways this is the generalized formula, but this formula, whether this can be used apart from the cases of ultimate settlement, that has to be taken care of. Let me see whether 50% settlement we have considered this formula mb del sigma, but here okay, even if you don't consider over here this rho equal to Cc, what is the formula? Cc by 1 plus E0, right? H log to the base 10 sigma 2 by sigma 1. Okay, even if you don't consider this formula over here, using this formula, if all the other factors are constant, that is Cc, E0 is constant because same time of soil, same situation, so log, so again rho A by rho B equals to HA by HB. Okay.
Yes.
So, better we do not use the formula for the ultimate settlement, we use the general formula to find out the settlement as per the increment in effective stress at any particular stage of consolidation. Okay. Because this is the formula for ultimate settlement. Okay. So, have you got 18.8 mm?
Mm.
Yeah,
Yes, sir.
you'll get it.
18 point.
18.8. Yeah, you'll get that. Just a moment. This document takes so much time to save. Okay, so next question. I believe it has recorded. Yes. Normally consolidated clay settled by 2 centimeter. Okay, this is very interesting. You see, so del H settlement is equals to, we know, Cc by 1 plus E0 H into log to the base 10 sigma by sigma 0, if I just write like this. So now we have only sigma. Okay, we have only sigma. So take this entire part as constant k, nothing is given. Okay, so in the first case scenario, del H is given 2 centimeter, divided by log to the base 10 200 by 100, you get 6.644. Now in the first case 400 kilopascal, del H 400, k log to the base 10, sigma 1 is 400 and sigma 0 is 100 initial. The value of k 6.64, approximately 4 centimeter settlement. In the next case, del H for 800 kilopascal, again k log to the base 10, final sigma by initial sigma, approximately I will think you will get 6 centimeter. Clear? So the part which is not given, take it as a constant, find the value of the constant using one given scenario, and then use the constant to find out the settlement in the other two scenarios, where only the increased effective stress are given. Okay.
Sir,
Yes.
here a small clarification. I think I understood this example.
Mm-hmm.
Same concept can be used, for example, at the last line. If you see, if the pressure is increased from 400 to, instead of here, the ratio is double.
Mm-hmm.
Therefore, instead of this one, if the effective stress is increased from 400 to 1000 kPa, if they give, also we can do it. Sir.
From 400 to 1000.
1000.
Yes, once you have got the value of k, okay, whatever the ratio,
Constant.
yes, whatever the
Yeah.
ratio you can find out, because here I have mentioned increased 2. So the
Yeah.
question lies in increased 2 from what? So initially it was
Mm.
100. So 100 is the
Mm.
base right now. So now if you have found out, now there is another I think important thing to note, that whether when you are considering 400, then at that time this value E0, now it is increased from 100 to 200, right? So I am
Yes.
considering E0 to be at 100 kilopascal, right?
Mm.
But if I consider 400 to be the base, to be the standard, will E0 remain same? No, E0 will not be remaining same, right?
Yes, sir.
Yes. So E0 not remaining the same, and Cc is how much? Cc is del sigma del E divided by log to the base 10 sigma 2 by sigma 1. Okay. So whatever we are changing the range of the void ratio, Cc might also change. For a particular stage it will be same, because the range of stress increment and the range of void ratio, it shows the trend, right? But E0, what about E0? If E0 is changing, then we cannot take 400 as the base. We have to take, here we are considering 100 kilopascal to be the base, because see, for E0 we are taking sigma 0, right? Sigma 0 is 100. We are finding out the value of k. No, you can't take like that. I am sorry, because we are finding out k taking the initial effective stress as 100, isn't it? So that only we have to consider, because k consists of E0, which is a part of this initial value. If we increase the sigma 0 from 100 to 400, then obviously the value of E0 will change, because the void ratio at 100 kilopascal and the void ratio at 400 kilopascal won't be the same, right? So this value of K is based on the initial effective stress of 100, and whatever value, if I say the stress has been increased to 1000, then log to the base 10 1000 by 100 we have to consider, okay, because the value of K has been taken with respect to 100 kilopascal as the initial effective pressure.
I am not changing the first two lines. First two lines it remains same. Last line, for example, calibrate the settlement when the effective stress is increased from 400 to instead of 800 in this question, 1000 is there.
Yes, it is and over here, right? 800,
Yeah,
800 and 1000. So just put over here 1000 and divide by 100, you will get it.
yeah, that's what I'm asking, sir.
Yeah, that you can do, but
Okay.
from 400, when you say from 400 to 1000, that is the time you are just implying that the 400 is the initial, okay. That is where I had a problem, that 400 can't
Okay.
be the initial. Increase to 400 at one point of time and then to 1000 from 100 kilopascal every time,
Okay.
okay. That is
Okay.
something we can do, and it is feasible, it is correct.
Okay.
Okay. Okay, again it will take some time to save. Okay, last question, saturated soil has a compression index. So here in the first question, change in void ratio. So change in void ratio you can find out from the compression index, Cc log to the base 10 sigma by sigma 0. All the values you have, right? Cc you have how much? 0.28. Sigma 0, 12. This is sigma final. So putting all the values, approximately you will get 0.0715. What is happening? Yes, this is the value of the change in void ratio, okay. Now let us find out the settlement in a different way, not using the formulas. Change in height divided by not height, sorry, thickness, I am uttering height every time. Change in thickness by original thickness equals to change in void ratio divided by 1 plus initial void ratio, okay. So the settlement will be del H equals to H into del E divided by 1 plus E0, okay, 1 plus E0. So E0 is 2.05, 2.05. Del E we have found out. What is H? H is 6 meter. Now the value of the settlement is approximately 0.141 meter, okay. Any doubt?
No, sir, clear.
Okay. So even if you haven't solved these questions by yourself, have you understood the solutions?
Yes, sir, 100%. I
Yes.
understood.
Okay. So I believe this was the last session, right,
Yeah.
with me, and I believe you have got a mail about tomorrow's session. Tomorrow's an extra session
Yes.
from 4 to 5.
Yes, sir.
Yes. So that will be the summary session. Okay,
Mhm.
that will be the summary session. I will be taking that because to complete 25 number of classes, and in that session I will be uh, talking about mostly the conceptual things. There won't be so many numericals, mostly the conceptual parts, a revision of the conceptual parts, whatever we have done in the 12 sessions, that will be there, okay, tomorrow.
That 3 to 5, sir.
No, it's a 1 hour session from 4 to 5, I believe. Just check, I'll see. Wait, I'll just check.
Okay. There are so many 3 to 5 one class is there GT1 after 5 to yeah, 5 to 7 is the GT2 is there.
5 to 7, okay, no, not 5 to 7, it is 4 to 5. My session will be the summary session. Yes, there will be interaction session. Yes, April 12th, that is tomorrow, April 12th, Saturday. Time is 4 p.m. to 5 p.m. Yes, the same link, same video link. Okay, if you
Okay,
can,
sir.
you can join, no issues. Okay,
I will join,
just
sir. I will join.
yeah, just some overall discussion on the conceptual parts of the 12 what to say courses, 12
Sir.
chapters of this course. Okay.
Okay, sir.
Okay, so
Thank you, sir. Thank
thank
you.
you for attending the class. We'll see you tomorrow if possible.
See you, sir.
Okay, yeah, bye.
Bye, sir.
Hmm.